Grade 12, 12, 12, 12, 12, 12th grade. That's who you want. That's who I am looking for. Grade 12, grade 12, grade 12. Yeah, so I'm going to session, guys. That will be followed by grade 11 session, back to back, and then yeah, I will call it a night today. So just two sessions, one grade 12, which I'm doing now, and then another grade 11, which I will have shortly after I'm done with the grade 12s. Okay, and yeah, if there's any grade 12s in the house, I hope you guys are well and you are good. So this is a grade 12 session. Yes, it's a grade 12 session. Grade 12, grade 12, grade 12. So any grade 12s that are in the vicinity, that would be awesome. That would be great. Yeah, absolutely would love and happy to have you. Can I just get an indication if there are any grade 12s here? And secondly, how is the network? Is the network fine? Can we hear me well? Audibility fine? Do you see a white page in front of you? You know, that type of thing. White page in front of you, audible. Are you hearing me? Are you hearing me well? Is the network okay? Is there a lag? It's grade 12. Okay. Okay, let me just write it down because I feel like everyone's going to be asking me the same question. Am I audible? Can we hear me? Grade 12. We'll have a grade 11 session after the grade 12 session. It's just that I haven't had the grade 12s in a very long time. I feel like I have lost touch with them, like completely. So can I get a indication from in the comment section that grade 12s are in the house? The people that are from grade 12, can I just get in that indication? And for those who are joining for the very first time as a grade 12, I just want to say there have been sessions that I've been holding for the grade 12. So I'm continuing on with the grade 12 learners from where I left off. But what we are going to look at is problems that have to do with sequence and series. We're still in the topic sequence and series, but under that topic we are actually going to be looking at a subtopic of that, and that is problems that require use of simultaneous equations. No, Kohle, doing function is not in the program. I will do functions in the future, but now, for grade 12s, because it's grade 12s, no, I'm not going to do grade 10. I'm not doing grade 11 now, I'm doing grade 12 now. And hopefully we'll just have an hour session, which will lead from 11 minutes past 8 now up until 11 minutes past 10. Not 11 minutes past 10, 11 minutes past 9. Then after that, I will have a grade 11 session. Okay. So unfortunately, for all those who are commenting in my comment section and they want something else, unfortunately, you won't be having that particular thing now, because like I said, I am doing a sequence and series, and specifically I'm going to be looking at problems that require the use of simultaneous equations in sequence and series. So that's what we'll be focusing on today. Everything else obviously will follow after that. We are still sort of like in the early beginnings of the use of the ATP. Yes, definitely using the ATP. And if you're a school that has started early in the syllabus, then of course you are probably doing something else. But according to the ATP that I'm using, which is in the area that I'm actually residing, it's sequence and series. That's the first topic, and it's followed up by functions or inverse functions. So I will only be doing inverse functions after I've done sequence and series. So if you are probably residing in a different place, or maybe your teacher may have seen it fit to start with inverse functions, then that is just the order that he has chosen or she has chosen to take. but according to the order of what is stipulated in the ATP, and that is a national ATP that I'm talking about. We're starting off with a sequence and series, and then we'll take it up with functions, inverse functions, after we've done with sequence and series. Okay, so to the grade 12s who are here, you are welcome, and it's really sweet having you. It's actually awesome to even have people that have been here, obviously, and who are actually just coming in for the follow-up session that we have basically been delayed. We've delayed that for a very long time, haven't we? But of course, there are other priorities that call, and so yes, that's why you have not seen me around, at least showcasing some lessons on the grade 12 syllabus. So nonetheless, so today we are actually now taking it up to the next thing that follows that, and that is problems that require and obviously there's also a mix or an integration of other types of equations in grade 11 because it's more advanced. Okay, please check your network. Thank you for that. More. How is the network now? I actually just try to do some tweaking to it and see if it will not be any different. It says good connection my side. I just need to confirm if you guys are actually receiving. Yeah, the network was bad. Yeah, I think it was very bad, but now it should be stabilizing and it should be good, because at least, oh my soul, okay, it is jumping between good and stable. It's better. Okay. All right, so let's look at this then for a moment. So problems that require the use of simultaneous equations, and this is under the topic sequence and series. Now, when we don't have three terms, usually most in a sequence, you'll always have a list of three terms, right? But what happens in a situation where we do not have three terms, but we are given some terms? Okay, so it means we are given some terms, and those terms could be scattered terms. Maybe you are given the 8th term, and then you are given like the 20th term, and for some odd reason or another you need to find the first term, but you have been given two like interspersed or sporadic terms that are far apart from each other. So what do we do in a situation when we are given some terms and not necessarily the first three terms? Because what's nice is when we are given the first three terms, there's a lot of things we can do. We can find the nth term, we can find all the other possible terms in the sequence, so that's what's beautiful about being given three terms. Plus, even if we don't know what type of sequence we are given is, we can always figure out the type of sequence that we have been given just based on the three terms that have been listed. So now we are saying when we don't have the three terms, but we are given some terms, or let's say, or sums of terms, meaning an addition of terms, all right? Then in that situation, we are forced to actually use simultaneous equations to what? To get the values of, and if it's an arithmetic sequence, we can get the values of A and D. If it is a geometric sequence, then we can get the values of A and R. So basically what we are saying here is that whenever we have a situation where we are not given the list of three terms, but we are given some terms, could be a situation of being given some terms, all right, or we are given sums of terms, okay, meaning a sum of terms, whether that be geometric or arithmetic, we will then have to use simultaneous equations. Yes, Wilmo, it's grade 12. We'll have to use simultaneous equations to get the values of A and D. In the case of arithmetic sequence, to get the values of A and D, we'd have to use simultaneous equations. Or in the case of geometric sequence, we'll need to find the values of A and R. Okay, so let's look at an example here. Here it is, and we will then attack it, address it, and marinate it, and yeah, just be satisfied with it. I'm sure you guys have had your Sunday meal and you feel very full and good. If you had dessert on top of that, I'm sure you're like feeling so great and amazing and awesome, and it's like life is great, life is good. In the middle of January, you have a full meal and you have dessert on a Sunday. So in a arithmetic sequence, here we go. In a arithmetic sequence, so I just used AS for short to mean arithmetic sequence. The third term is 13. Do you see this, guys? We are given a third term, and it is equal to what? To 13. The eighth term is 38. Okay, so do you see this? Right? We're given a third term and an eighth term. Now, I mean, these two terms, they are far apart from each other. They are not even consecutive terms immediately, you know. So they do not even follow each other immediately. So it's not like we can find the constant difference, okay? And we don't even know the first term of the sequence. So all in all, what I'm saying to you is that since we are given the third term, which is 13, and the eighth term, which is 38, we are now being asked to find the first three terms of the sequence. Now, the million-dollar question is, how in the world then do we go about finding the first three terms of the sequence? So if we go back to what we had stated before, when we don't have the first three terms of a sequence, but some of the terms, some of them, okay, then we will use what? We will use simultaneous equations to what? To get the values of A and D and R. And hopefully then that will help us to be able to eventually get to the nth term, which will then hopefully help us to get to the first three terms. Okay, so let's look at this. The third term is 13. So let us be honest. When we say the third term is 13, that means T3 is equal to 13. I hope we all agree. Okay, so that's T3 is equal to 13. And the eighth term, meaning T8, is equal to 38. Okay, so I'm sure you guys can see that from this, voila, I have equation 1. Voila, I have equation 2. And then, I'm sure you can remember from earlier on in the lessons that we had done on sequence and series, that term 3 can actually be represented in terms of A and D. Do you still remember that? T3 can be written in terms of A and D, seeing as though the particular sequence in question here is a what? Is an arithmetic sequence. Remember, the general term for an arithmetic sequence is Tn is equal to A plus N minus 1 D. I'm sure you guys still remember the nth term here. The general term of any arithmetic sequence is given by this formula. Tn is equal to A plus N minus 1D. Now, in terms of A and D, what is T3? So if we were to just substitute T3, all right, meaning in the place of N, we are going to substitute 3. We have A plus 3 minus 1. This is just to remind us, this is something we should know, that ultimately will give us A plus, what's 3 minus 1 inside the brackets? That gives us 2. And 2 multiplied by the D. So that means T3 is in actual fact equal to A plus D. And this is the expression in terms of A and D that we are going to utilize, and we will equate with the value of the term, which is 13. I hope that makes perfect sense to you guys. And so what you should have noticed is that the coefficient of D is always 1 less than the term position. Okay. Now remember, we had T8 as well. Okay. And off by heart, I'm sure you guys can tell me what T8 is in terms of A and D. I won't plug it in and substitute, but I'm sure you can see. So what's T8, guys, in terms of A and D? You saw what that T3 is equal to A plus 2D. So what's T8 in terms of A and D? What do you guys get? Let me allow you guys to actually type it in the comment section, and then I will take the lead of what you guys say. All right, Sbani is feeling the fire and the goodness and the warmth. Okay, Wilmore, Nda, Sbani, you guys are spot on. It's A plus 70. Slibo, this is grade 12. Grade 12, say. So term 8 is equal to A plus 70. Okay, A plus 70. So this is definitely the expression that we want to be taking and we will be equating that with 38. So if we rewrite these two equations, rewrite in terms of A and D. And this terminology of saying in terms of something, rewrite in terms of A and D. We are going to rewrite the two equations we had set up, but this time round we are going to write them in terms of A and D. So T3 is A plus 2D. So in the place of T3, I'm substituting A plus 2D. And then on the other side, I equate that with 13. So this is my equation 1. Do you see that? Then my equation 2, T8, remember T8, I had actually found out that T8 in terms of A and D is A plus 7D. So I set up the second equation, writing T8 as A plus 7D on the left hand side and then equating it with 38. Okay, and that is my equation what? My equation 2. Okay, so guys, I hope you can see the value of these types of questions. Whenever we are given terms, look at the question, in an arithmetic sequence. So we are taking our lead and our guidance from the fact that we know that the sequence is an arithmetic one. And because it is, we are told that the third term is 13, and we are told that the eighth term is 38. So these are two equations we can set up based on what we see in these statements. Third term is 13 means T3 is 13. Eighth term is 38 means T8 is equal to 38. In terms of A and D, how do we write term 3? And I showed you practically that if you take the general term, because we know that the sequence here is an arithmetic sequence, we take its general term and we substitute 3 so that we can be able to get what T3 is in terms of A and D. Okay, and then again, T8 we can represent as well in terms of A and D. And what you should clearly notice is that term 3, the coefficient of D is always 1 less than the term number. Again, this is term 8, and 7, the coefficient is 1 less than the term number. So the expression then that we utilize for T3 is A plus 2D. On the other side, we write equal to 13, that's equation 1. A plus 7D is equal to 38, that's equation 2. And so you can see that in these two equations, we are now smack bang exposed to that type of equation that we used to solve in what? In grade 10, which is called a simultaneous equation containing two linear equations. All right. And so there were two methods that we learned in grade 10, and that was the substitution method or the elimination method. Okay. So if we use quickly the substitution method, we have A plus 2D and we have A plus 7D. All right, there was the substitution method and the elimination method for two linear equations. All right, so I'm just going to look at both, okay, so that you guys can just appreciate then again the method maybe that you used to use and which probably helped you or fit what you'd like to do. So if we take A plus 2D, we make A the subject of the formula, and then what happens? 13 stays on the right hand side, 2D is transposed and it becomes minus 2D. And then we usually say that's equation 3. Then what we do is we substitute equation 3 into equation 2. All right, definitely take equation 3, which is the new equation 1, because we made A the subject of the formula, and then we transpose the 2D to the other side, it becomes minus 2D. We substitute this equation into equation 2, which is this one. All right, so that means everywhere where A is, we are going to substitute 13 minus 2D. So let's rewrite equation 2, A plus 7D. So in the place of A, we write 13 minus 2D, followed by what? Plus 7, plus 7D, followed by what? Equal to 38. So hopefully you saw that, guys, that in the place of A, we substituted 13 minus 2d in this second equation. In the place where a is in the equation 2, we substitute 13 minus 2d. So there is a, so we substitute 13 minus 2d, followed by plus, there's the plus, 7d, there's the 7d, equal to 38, equal to 38. Then we solve for the variable that is there. So minus 2d plus 7d is 5d. We take the 13, we transpose it to the other side. When we transpose terms onto the other side of the equal sign, they change sign. So 13 that was positive is now negative. Then 5d is equal to, what's 38 minus 15? That is 25. And then after that, what do we do? Since 5 is multiplied to the d, we divide both sides by the coefficient of the variable d. The coefficient is 5, so we divide by 5. If the coefficient was negative 5, we would divide by negative 5. But what we do on the left, we do on the right. And then the final answer is d is equal to, what's 25 divided by 5? It's smack bang equal to 5. Okay. So we have found the value of d. What is missing? We need the value of a. Okay. Are we together so far, my beautiful grade 12s? Anyone who is sort of like lost, especially I'm talking to the people who have been here like smack bang from the beginning, that actually saw the problem as it developed from the beginning. Of course, if you just join in the live now and you see it, you're like, what's happening here? I mean, that makes a lot of sense, but I'm just checking the people who were lost. Now remember, we are not done, right? Because we wanted the value of a as well. D is equal to 5. Now let's go and find the value of a. So we take this d and we go and substitute it back into equation 3. Okay, because it's weighting. All right. So we go and substitute d is equal to 5 into equation 3. Because equation 3 is sort of like weighting. It's waiting for what? For d to be substituted so that a can be found. So let's go. A is equal to 13 minus 2. In the place of d, where d was, we substitute the value of d, which is 5. So there it is. And then a is equal to, what's 13 minus? What's 2 times 5? 13 minus, what's 2 times 5? It's 10. Are you with me? And then what's 13 minus 10? A is equal to 3. Okay. And there we have it. There is our first term. Okay, remember the value of a means the first term. Okay, the value of a means the first term. And remember the question was asking, find the first 3 terms of the sequence. All right, so let's just go back a little bit for those who just joined in, guys. We were looking at this questions that lead to simultaneous equation in sequence and series. So we're given a question here, and it says, in a arithmetic sequence, the third term is 13 and the 8th term is 38. You can clearly see if this is the third term, it's far away from the 8th term, and these terms are not close to each other at all. The question says, find the first 3 terms of the sequence. So we clearly have to set up equations from these statements. From this one that says third term is 13, this simply means mathematically in sequence and series language, T3, meaning term 3, is equal to 13. Hopefully we all understand this. It's very clear. The fact that they say 8th term is 38, in sequence and series language, that simply means T8 is equal to 38. So there we have it, equation 1 and equation 2. But we are aware that term 3 and term 8 can be expressed in terms of a and d. So we rewrite these 2 equations, especially what is on the left-hand side. We rewrite it in terms of a and d. All right, how? We simply take T3, we go and substitute it into the general term. Since we know that the general term of an arithmetic sequence is Tn, this is a formula, is equal to a plus n minus 1d. We go and substitute T3 there and mathematically, as we simplify, we get T3 is equal to A plus 2D. This is an expression of term 3 in terms of A and D. A plus 2D. Then we go and take term 8. And I said, I'm sure you guys can see that if we substitute term 8 there, it just means we are going to say 8 minus 1 there, we're going to get a 7. So that's why T8 is actually equal to A plus 7D. These expressions respectively can then be substituted in the place of T3. We have A plus 2D. Do you remember? T3 was equal to 13. Okay? And then in the place of T8, we can substitute A plus 7D, which is equal to what? 38. And these are two equations. In grade 10, you used to solve equations of this nature. They were referred to as simultaneous equations, and they were both linear in grade 10. Okay? In grade 10, that's where you learned how to solve these types of equations. And so there were two methods. One was called the substitution method, which is what I used to solve this particular equation. The substitution method, you simply took one of the equations, you made the variable, one of the variables, the subject of the formula. Okay? And when I say that, it should also ring a bell, making A in this equation the subject of the formula, isolating A. Transposing 2D, you get 13 minus 2D, which is the value of A, and then you refer to that as equation 3. You take that equation, and you know almost, it's saying A is equal to what? 13 minus 2D. In other words, you take this equation, you substitute equation 3 into the other equation that was not touched. Which is the equation that was not touched? Because remember, equation 3 is made from equation 1. The untouched equation is equation 2. So you take this equation 3, you substitute it into equation 2. So where A is, you substitute what? 13 minus 2D. So let's come to this equation. Where is A? It's here. What do we substitute? 13 minus 2D. There it is. 13 minus 2D. 13 minus 2D in the place of A. 13 minus 2D in the place of A. And then what follows the A? Plus 7D. Plus 7D. Then what follows that? Equal. The equal sign. What follows that? 38. There is 38. And then after that, what do? You solve for the variable that is the only variable, which is D. So minus 2D plus 7D is 5D. You take the 13, you transpose it to the other side. 38 minus 13 gives you 25. So you have 5D is equal to 25, which means when you want to solve for this D, you need to isolate it. The 5 is multiplied to the D. So you need to then do what? Divide both sides by the coefficient of D, which is this 5. You divide both sides by that. What you do on the left, you do on the right. You get a value of D, which is equal to 5. When you have that D, which is equal to 5, you then need to go ahead and find the value of A. You take the D, you go back to equation 3. It is waiting. What is it waiting for? Equation 3. Equation 3 is waiting for D so that we can find what? A, who is isolated. We are waiting. Where is D? D is equal to 5. So we go and substitute D is equal to 5 into equation what? Equation 3. There it is. A is equal to 13 minus 2. There was D here. We substitute in the place of D the value of 5. Then minus 2 times 5 gives us negative 10. Negative 10. Remember, BODMAS, we need to first multiply and deal with the brackets before we say 13 minus. You can't say 13 minus 2 and say it's 15, then say 15 times 5. You can't do that. BODMAS does not allow it. So you have to multiply this negative 2 and the 5. You get negative 10. And then what's 13 minus 10? You get positive 3. So the value of A is equal to 3. So A is equal to 3. D is equal to 5. But what is A, guys? In a sequence, what is the value of A? What do we refer to A as in a sequence? Someone tell me in the comment section. A is called the... Because remember, the question said, find the first 3 terms of the sequence. So A is the... What is A? Yes, A is a variable, but more than that. Okay, Crystal, Wena, you are the woman. Wilmore, yes, Wilmore, amazing. Annika Erasmus, on the money. Nda, definitely. So yes, A, I like what somebody said there. A is a variable. Yes, A is definitely a variable. But what does it mean? A is what we refer to in sequence and series as the first term. So that means the sequence starts with 3. What is D? What do we refer to D as in a arithmetic sequence? What do we refer to D as? D is the... Yes, Wilmore, it is the constant difference. Man, I love it when people just give answers that are sweet and delicious and yummy and, you know. I mean, this must be dessert, guys. I mean, I think we're having dessert right now. So then what do we do to find the next term? Okay, because we want the first 3 term. We have our first term. We just need 2 more terms. So what's the next term? Because I'm going to write the first 3 terms. That's what the question asked for. Okay, and finding A and D is not enough. Okay, to get the next term, what do we do to the first term? We have the constant difference, it's 5. So the next term will be equal to, I'm sure you guys know this. We are going to add the value of what? Of 5, right? And then the next term will be equal to 8. All right? And then again, if we need the next term, we are going to add the value of 5. And the next term will be equal to what? I'm going to wait for you guys' maths. My mom just sent me this link. She did. How kind. I hope you will go and give your mom a very big hug. Your mom loves you a lot, that's for sure. If she sent you this link, your mama loves you. And you think your mama doesn't love you. Your mamas love you. My goodness. Why would your mama send you this link? Yeah. Hopefully you can go and express your immense gratitude to your mother. Yeah. Mothers love being appreciated by their sons, by the way. Hey? They do. They absolutely do. Because funny thing or the weird thing is that to your mothers, you guys resemble your fathers. And oftentimes, maybe just depending on the situation, you know how it can be sometimes. So if you boys can actually show your mother's love, they will really appreciate it a lot. And we need more boys that can appreciate their mothers. So anyways, 3 plus 5 is 8. 8 plus 5 is 13. Because this is what we refer to as the first difference. And it is usually constant for a what? For an arithmetic sequence. This is very key. 8 minus 3 will give me this 5. But I must also know how to get the terms, guys. Let's not forget this thing. 3 plus 5 is 8. 8 plus 5 is 13. Okay, we don't necessarily have to go ahead and find Tn in order to find the first 3 terms, because we know that the constant, if we have the first term, then getting the next term and the next term is a matter of adding the constant difference to each successive term. Okay, so I mean to each previous term to get the next term. So I hope that makes perfect sense and is clear. All right. Someone have a question? Does anyone have a question in particular? I know, for instance, someone asked, can't I use another method as far as like the simplification part? Oh, no, nda. I think like in, is it vendor or something like that? I don't know if that's an expression of gratitude. I'm not vendor, but yeah, thank you so much, nda. Really appreciate it. A plus. I just want to check this other method because someone probably was like, can't we use an alternative method to solve for A and D? Thank you so much, and I really appreciate the ice creams, bro. I really, really do. So A plus 2 is equal to 13, A plus 7, D is equal to 38. Some people use what we refer to as the elimination method. The elimination method in grade 10, all right, unlike the substitution method, all you have to do is to check the variables. It's like you align the variables underneath each other. You look. The A, look at the coefficient. It is the same. So the coefficient of A is 1 and the coefficient here of A is 1. They are both positive. So if I take equation 1 and I take equation 2, because I have same coefficients, all right, and the signs of the coefficient are the same. If the signs of the coefficient are the same, all I need to do is just give an instruction that equation 1 subtract equation 2. So if I take equation 1 and I subtract equation 2, let's just subtract in columns like we used to do when we were in primary school. So if I say equation 1 minus equation 2, that means what's a minus a? That gives me 0. In that way, I eliminate a, okay? Because I gave the instruction equation 1 minus equation 2. So we're going to do the same thing with d. 2 positive 2 minus positive 7. So what's 2 minus 7? That is negative 5d. Are you with me? Then we do the same thing here. What's 13 minus 38? That gives me negative 25. So this is what the elimination method is. The elimination method is about first checking. It's about making sure that the coefficient of either a or d, at least the coefficient is the same, for either d or a. So in this case, we have the same coefficient for a. So therefore, we can instruct that equation 1 subtract equation 2. And by doing that, a minus a is 0. I've eliminated a. D still remains. I get negative 5d. 13 minus 38, I get negative 25. Now I can solve for d, which means I divide both sides by negative 5, the coefficient of d. What I do on the left, I do to the sweet right. Yes, you can do that, Devin Willemser. You can say equation 2 minus equation 1. That way, it will be like saying a minus a, which is 0. Then you'll say 7 minus 2. That will give you positive 5d. And then you'll say 38 minus 13, which will give you positive 25. All in all, it will all lead you to what? D being equal to positive 5. So you could do that, Devin. You can do that very well. Oh, nda, bruh, donut. Mwah. Guy, this guy knows how to light up a man's a gift gallery. But on top of that, just to make sure that dessert is truly served, I smell some sweetness in here. Okay, so d is equal to 5. So we have d, guys, which is equal to 5. Do you see how we got d? I hope you guys understand how we are able to get this d using the elimination method rather than using the substitution method. So you need to acclimatize to a certain method and then you roll with it, okay? The method that you feel most comfortable with, you must roll with it and you must use it, all the time. Yeah, it works the same, buddy. Definitely does, Mr. Doing. What a name you have, by the way, Mr. Doing. Yeah, man, guys are pretty creative up here in the TikTok industry. Okay, now that you have d, you can go to any equation now and they go and substitute the value of d. So let's say we just take equation 1. And all we simply do is we take this 5 and we substitute the value of d in one of the equations. Choose any one, doesn't matter. Any one of the equations. And what that will do is that you'll transpose the 10, 13 minus 10, a will give you 3. So there you have it, guys. You still have your d, which is equal to 5. You still have your a, which is equal to 3. Now you want to write down your sequence. You know that the first term is 3. So the constant difference is 5, which means we're adding 5 all the way. So what's 3 plus 5? It's 8. What's 8 plus 5? It's 13. So there again, we have our sequence 3, 8, and 13. Okay. Aye. Option B is way better. It's simpler. Osman is like, hey, Mr. Lights, Mr. Lights. Nda, my leader. Thank you so much, man. Thank you. I really appreciate it a lot. This is what you're doing is very rare. So that's why I'm kind of acting up here with you, dropping these sweet, beautiful perfumes and all these other stuff, Mr. Doing is like it's for the lazy. Nda is definitely a legend. No, totally. And Siseke my leader, you are going to go to the Mother Mosque and do the things that need to be done the minute we are done with this thing, right? Because, a sense of gratitude. Gratitude touches the heart, man. Truly does. Mothers love it. Okay, anyways, let's come here. Next question, next example. Let's look at another example, guys. That one was a nice one because what it does, and this is the beauty of the sequence and series, guys. Don't take sequence and series for granted. Some of you want to go to the other topics that are much more whatever. But let me tell you this one thing: for a grade 12 learner who wants to recap nicely on the algebra that you did in grade 11 at the beginning of the year, and some of your grade 10 algebra, doing sequence and series and doing the exercises, like the textbook exercises, getting the practice in, driving in the concepts, it's good that you do that thing, guys. It helps a lot because you need to get back, you need to get your A game on when it comes to algebra. And in order to get your A game on in algebra again, you need to do these exercises, and you need to implement the concepts, that you've learned. So it's good to actually do these problems and to just ride it out all the way. Okay, so let's look at this question. Thank you so much, Agenda. You know, Mos, I appreciate my leader. I appreciate a lot. The heart is overwhelming with all sorts of ice cream goodness. If the seventh term of an, and you must note now, arithmetic series, okay, if the seventh term of an arithmetic series is 16 and the sum of the first 10 terms is 115, determine the first term of the series and the constant difference. Okay, let's go back again. It says if the seventh term of an arithmetic series, very important here, we're talking about a series that is arithmetic, and we are saying the what? The seventh term of that arithmetic series is 16, and the sum of the first 10 terms, so we are talking about what? The sum of the first 10 terms, okay, is 115. Okay, determine the first term of the series and the constant difference. Okay, so let's look at this, guys. Let us unpack this one at a time. So remember, you can see from the statement that we are talking about a seventh term of the series, of the arithmetic series, and we are told it is 16. So honestly speaking, what we are saying is that we are saying that T7 is equal to 16. But someone will say to me, but sir, isn't this a series? And isn't a series like a sum of terms? Yes, a series is a sum of terms, right? But what we are told here is that the seventh term, in other words, they are stipulating a term in that series which is equal to what? 16. And what is that term? It is the seventh term. So we have to then say T7 is equal to 16. That is seemingly one of our equations. Writing it in terms of A and D will follow. But at least we've been able to extract from the statement that T7 is equal to 16. Let's move on. And the sum of the first 10 terms. The what? The sum of the first 10 terms is 115. Now here we are told the sum. So what does that mean? It means S10, not T10, because we are being told the sum of the first 10 terms is equal to what? Is equal to 115. So that will be our equation too. Oh, thank you so much, Petronella, hearting me and then joining the team and the two roses. Hi, thank you so much. Much appreciation. S10 is equal to 150. So guys, I hope you can get the information we've been able to extract from the statement All right, and I'll reread again. If the seventh term of an arithmetic series is 16, okay, that's why we said T7 is equal to 16, and the sum of the first 10 terms is 115. Sum of the first 10 terms, we didn't say T10, we said S10 is equal to 115. Determine or determine the first term of the series and the constant difference. So guys, here we have our equations that we need to set up. Now, what sequence or what type of series is this? It is an arithmetic series. Now we need to recall the formulas that we use. For Tn, it's a plus n minus 1d. We can remember that. Okay, and I'm very sorry for the doctor handwriting. Yeah, they did tell me that I was actually supposed to maybe have been that. Now you see, now I'm having problems here. Then that's Tn. For Sn, you remember that for Sn, for an arithmetic sequence, this is the formula. Okay. What's beautiful is that these formulas will always be provided in a formula sheet, so we need not ever be at loss. Okay. But what we want is to express T7 on the left in terms of what? A and D, and hopefully also S10 in terms of what? A and D. All right. So we can just quickly go and get what those expressions are very quickly. So Tn, let's substitute T7 so that we can get our expression. And I'm sure off by heart you even know what it is. Okay, you don't probably need to even do what I'm doing right now, because you know that T7 will be equal to A plus 60. This coefficient of D is always one less than the term number. Are we together? So this is the expression we want to extract and go and substitute in the place of T7. Then moving right along, let us go and write S10. That will be in the place of n, we substitute 10 over 2, 2a plus, then minus 1 into d. All right, then 10 divided by 2 is 5 into 2a. Okay, 2a is 2a plus 10 minus 1, that gives you 9 what? 9d. All right, and please take note of the brackets here, guys, that obviously the formula itself is n over 2, and there's a bracket that basically covers everything that we have here. Then there's 2a plus, which is separated from n minus 1 and the multiplied by d. So when we say 10 minus 1, we get the 9, and the 9 gets multiplied with the d. Inside now we have 2a plus 9d. Then the 5 is waiting patiently outside the bracket. So what do? There are two terms inside the bracket. We distribute 5 into 2a and 5 into 2d. Make sense? So what's 5 times 2a? When we multiply the sign, the number, the letter. 5 times 2, positive times a positive, positive. 5 times 2, 10, the number. Letter A smack bang next door. 5 times 9, positive times a positive, positive. 5 times 9, 45. D smack bang next to it. So in other words, S10 is equal to 10A plus 45D. That is what we need to represent on the left-hand side of the equation for S10. So let's go and rewrite our equations in terms of A and D. Okay, guys, what I'm doing here, rewrite, I'm not gonna say these things, rewrite in terms of A and D. This is just for the purpose of you. When you're watching my video again on YouTube and you have forgotten, then you'll remember what I said and I actually wrote it down. Rewrite in terms of A and D, the equations. So T7, A plus 60 on the left, followed by equal to 16, equal to 16. Equation 1. Then S10, remember S10, we were able to substitute in the place of that Sn formula. That is an arithmetic sum of n. Okay, we were substituted 10 in the place of n, because S10 in the place of n we substitute 10. Then we simplified, we got 10a plus 45d. makes for easy manipulation. 10a plus 45d, which is equal to what? 115. Equation 2. Now I remember someone saying that the elimination method is for lazy people. Alright, that method, the one I used, the second one. Alright, so you see now, you see what the danger is in this problem. In this problem, the danger is, if you look at if we are wanting to use that elimination method, the one for lazy people, apparently, if you look at the coefficient of a for this equation, it is 1. The coefficient of a for this one is 10. So the coefficients are not the same. So it means we have a problem. If you look at d, let's say we want to eliminate d, we also have a problem. The coefficient of d here is 45. The coefficient of d here is what? Is 6. So those people who like the elimination method, they have a problem now. All right? But nothing to fear, guys. Nothing to fear. If you want to use the elimination method because you are obsessed with it, what you will have to do now is you'll have to look at the two equations and ask yourself, which letter would you like to eliminate? Maybe someone will say, I want to eliminate a. Why do you want to eliminate a? Because it's just easier, because it's the first variable in each what? In each expression. So then you conclude and you say the following. All right. Just like in grade 10, those people who will remember who used the elimination method, you look at this equation, the coefficient here is 1. You'd like to make it 10, right? So that it's like this 10 here at the bottom. So what you do is you say, equation 1, you are going to multiply by 10. Ebana. Do you see this, guys? Equation 1, EQ. You are going to multiply equation 1 right throughout by 10. So if you take this equation and you multiply every single term by 10, what happens? What's 10 times a? That's 10a. What's 10 times 6? 60d. What's 10 times 16? Equal to 160. That is the new equation 1. Do you see that, guys? Then this equation, it stays that way. 10a plus 45d is equal to 115. Now those elimination method people can work. But if they had left things like this, those elimination people wouldn't have been able to work. Okay? I hope these elimination people are listening very carefully. The elimination people. Alright? That's what you would have to do. You have to multiply by a certain constant, a certain value throughout that particular equation, so that when that particular equation is formed after having multiplied, it will ensure that elimination is possible of one of the variables. I hope you are with me here. All right? I really hope you are listening to me. Okay? And remember, since this is an equation, the integrity of the equation has not been lost. All right? Okay? Yes, Bani. Yes. One of the letters needs to have the same coefficient at the end of the day, so that at the end of the day, you can be able to do what? You can eliminate one of the variables. That is basically what you should have learned in grade 10, solidly so. And in grade 10, you should have been able to be exposed to both methods, so that you can then, at the end of the day, do what? Make a choice as to which one you want to use, and then run with it from grade 10 all the way to grade 12. Me, I don't like elimination method, but because I don't like it, it does not mean I cannot use it. I can use it because I know it. You know what I mean? Just because I don't like it does not mean I cannot use it. I can use it when I want. When I want to, I can use it, and I can effectively use it to be able to solve a problem. But I must say, I prefer the substitution method, because preference is something we all have, don't we? So now those elimination people, all you then do say here is you say equation 1 minus equation 2. And like my friend who was in the live said, you can say equation 2 minus equation 1. It's really up to you how you want to do it. So what's 10a minus 10a? A is gone. 60 minus 45, 60 positive 60. You actually read it like this: positive 60, whatever the sign is here, positive 60 minus plus 45, because you know most a negative times a positive will give you a negative. So that's why we say 60 minus 45. Okay, we actually take into consideration the sign of the 60. That's why I can say 60 minus. Okay, I gave the instruction minus, but a negative times a positive still gives me a negative. So I say 60 minus 45, which gives me 15D. Are we together? On this side, 160, the instruction is minus. Minus what? Positive 15. What's 160 minus 115? Zaza, I'm not sure I am hearing you. I'm not hearing there. Do we always need to add or MES? I don't know what MES means. Okay, thank you so much for saying 45. Hey, I was getting worried there. 145. Yeah. Okay. So 160 minus 115 gives us 45, guys. Totally 45. I mean, like, you know, like it's definitely 45. Like, it's no doubt about it, you know. It's like, seriously, like, it's like that way. So Uzaza there must rephrase her question. I don't understand her question there. Help me out, Zaza. I don't want to finish and I don't know what you are asking. 45 divided by 15, guys. Do you see? The answer is 3 indeed, Anika. It is like that. It is like that. D is 3, guys. D is 3. Now, since we have D, all we need to do is go to any equation. Okay, I can just grab any equation. I mean, I could even grab the before changed equation. You can grab any of these equations and substitute the value of D and solve for A. All right, any of them, it's okay. Now I'm going to take equation 1. A plus 6D is equal to 16. Make sure when you write it out, you write it out the way you wrote it down. Hey, don't want to be making silly mistakes at the end when we've gotten D. You know what I mean? Then we write A plus 6. So we substitute in the place of D the number 3. A plus 18 is equal to 16. A is equal to 16 minus 18. So A is equal to negative 2. See how nice that was? All we did is we substitute D into any equation. You can go to any equation in the equations that you had. Okay. Zaza, listen, Zaza, ne? You are asking, do we always need to minus? Remember, Zaza, ne? We are minusing here. Why? Because minusing will lead to an elimination of one of the variables. We need to have one of the variables gone. Okay, so we even did this strategically to these two equations. We took this equation and we multiplied it by 10 deliberately. Why? We could see that there's a coefficient of 10 for A. So in order to eliminate A and leave D alone, we multiplied equation 1 by 10. But we did that for every term. Multiplied A by 10, got 10A. Multiplied 6 by 10, got 60. Multiplied 16 by 10, 160. So what I'm saying is, that's what you do deliberately because you want to eliminate one of the variables. Okay. So it's very important that that is something that you do. I would rather suggest that if you have a question that's different, please make it a thing to just send me a message. You can send me a message personally, privately, like on my DM, and just harass me with it. I definitely will attend to it, and then I can answer you on your own if that's the case. Because the thing is, I don't want to deviate from what I'm doing right now. Okay, guys, the question was saying determine the first term of the series and the constant difference. Have we accomplished that? A is the first term of the series. So obviously the first term we have, first term which is a is equal to negative 2. Constant difference is 3. So we're good, we're done, we finished. First term a is equal to negative 2, d is equal to 3. Okay. So this is important, this thing of we need to read the question, interpret things correctly, know the type of sequence or series we are dealing with, then set up the equations accordingly, and then make sure that we are able to rewrite things in terms of the appropriate variable according to the type of sequence that we are getting. Okay. I think I'm going to look at one last one, guys. I can only do one last one for the die, for the die. Let's look at this one. In a GS, so this time round we are looking at what type of sequence instead of the sequence that we had been looking at, because we looked at we've been looking at a certain type of sequence, but now we are looking at another one. Do you know what a GS is? Yeah, geometric quotient. Is it quotient? Thank you so much, quotient. Very true. So we're in a geometric series. The sixth term is what? Is 8. Thank you, Keishan. Okay, I see. Sorry for butchering your name there. The sixth term is 8, right? And the 12th term is 512. Determine the sequence. So they just want the sequence. In a geometric series, in a geometric sequence. Now that's the thing. Now the key word here is that we are not dealing with a arithmetic sequence anymore. We are dealing with a geometric sequence. In the sixth term we are told is 8. So what does that mean? T6 is equal to 8. Equation 1. And the 12th term is 512. T12 is 512. Equation 2. Exactly, simultaneous question. Simultaneous. Now it's a matter of writing this T6 and T12 in terms of what this time round? In terms of what? In terms of A and R. Because we are now dealing with a what? A geometric sequence. Okay, Zaza, one more time for you. Zazazela. In a geometric sequence, the sixth term is 8. What? The sixth term is 8. So what do they mean, the sixth term? They mean T6 is equal to what? To 8. Then, and the 12th term is 512. The what? The 12th term is 512. T12 is 512. Now the question is, determine the sequence. They want us to get the sequence. Okay? Meaning that geometric sequence. And usually if we have 3 terms, it suffices to actually just give us a summary of the sequence, if you know what I mean. Okay? But in order to do that, we need A and we need R. Because this is not a arithmetic sequence, it's a geometric sequence. And we know that Tn, the nth term of a geometric sequence, is A times R to the power n minus 1. Because this is a what, guys? It's a GS, man. It's a GS. It's a GS. So therefore, we are dealing with a completely different formula, and we need to be aware of that. So that's why it's important to take note of what sequence they are referring to. We don't want to assume, or we don't want to just fall into the trap of like, oh, it's the same thing we've been doing. It's the constant difference. It is Tn is equal to A plus N minus 1D. We'll go wrong if we do that. So we need to always be vigilant and aware of what type of sequence they are referring to. Okay. So what is T6 in terms of A and R? T6 is equal to A to the power R. 6 minus 1, we know it's AR to the power 5. That is T6. That is the expression you need in the left here. AR to the power 5 is equal to what? 8. Equation what? Equation 1. Equation 1. Looking good, eh? Looking good now? Looking good, hey? Looking good, Keishan. And then we need T12 in terms of A and R. T12 is equal to 12 minus 1. We have AR to the power 11. That's T12. That's the expression we need on the left-hand side of the equation for T12. So we're going to replace T12 with AR to the power 11, which is equal to what? 512. That's equation 2. Yes, Keishan. Yes, Keishan. Alright, so there we have it, guys. See, 2 equations, both in terms of A and R. Now, very key what we do right here. Because this is the type of expression on the left that has a relationship of the variables that are multiplied to each other. Okay, how did we get 11 again, Zaza? Remember, this is a geometric sequence. Tn is equal to AR to the power n minus 1. So if we are going to substitute in the place of n 12, then it means on the right hand side we substitute in the place of n 12. But then we subtract 1 because the formula has n minus 1. So what's 12 minus 1, Zaza? For our general term, T12 is equal to AR to the power 12 minus 1. What's 12 minus 1? Then the exponent is 11. So T12 is equal to AR to the power 11. So what you should be noticing is that every time we are writing the general expression of a specific term, the expression on the left will always reflect for n, okay, or the exponent for r will always be 1 less than the given term number. T12, what's 1 less than 12? 11. T6, what's 1 less than 6? 5. You see what I mean? Even with when we're doing a plus n minus 1d, you know, T6 was equal to a plus 5d. So I hope you are picking up on the trend here. But it's always 1 less. Okay, very important. So AR to the power 11 is equal to 512. Okay, so people who are very well versed in this don't even go and do this on the side, but they just write obviously the given equation as per the statement. Then they show you how they've rewrite in terms of A and R. Their rewrite in terms of A and R, there we have it. Okay, they just go ahead into the rewrite because they know it's always 1 less. T6 is going to be 5 there. T12 is going to be 11 there, so they know that. And then, very important, what's the relationship between A and R? Multiply. That's what combines A and R, it's multiplication. What combines A and R here? Multiplication. A and R are combined by multiplication. This makes it 1 term on the left, 1 term on the right, because multiply combines terms. So what we are going to do here is we are going to say equation 1, in fact, okay, equation 2 divided by equation 1. Now, you are going to pause with me and you are going to ask yourself the question, why is this guy saying equation 2 divided by equation 1? Mind you, if I wanted to, I could have said equation 1 divided by equation 2. But there's a reason why I said equation 2 divided by equation 1. And I'm hoping you can look at the left-hand side and you can look at division of the left-hand side. If I take AR to the power 11 and divide it by AR to the power 5, and I'm going to deliberately do that, AR to the power 11 divided by AR to the power 5. Do you guys see what's happening here? If I divide these two on the left, what happens? A divided by A, the relationship between the variables and the bases are multiply and divide. Okay? Yes, man. You see how strategic I am, placing the bigger number at the top. I'm trying to avoid negative exponents as well. I'm trying to avoid fractions as well. All these other things, it's very key. Yes, Kishan, and the cancellation. Okay? I'm sure you guys remember exponents. If the bases are the same and you are dividing, what do? You keep the base, you subtract the exponents. 1 minus 1, is a to the power 0, which is 1. Okay. Repeat which part, Kuhle? Like literally, what part are you telling me to repeat? Did you get this part, Kuhle? This part, this one. How I got this, AR to the power 5 is equal to 8. Did you understand how I was able to get AR to the power 5 is equal to 8 and AR to the power 11 is equal to 512? Hopefully did that. The division part, okay. Now listen to the division part, Kuhle. I'm saying A and R have a relationship of multiply. People don't know that. You might not see the multiplication of A and R, but what combines A and R is multiply. What combines A and this R is multiply. Okay? So that means if I am in the business of wanting to solve for one of the variables, either R or A, then I have to divide, okay, equations together instead of adding or subtracting. I cannot say equation 2 minus equation 1. That won't help me with anything. I can't say equation 2 plus equation 1. That won't assist me in being able to solve for one of the variables. In order to solve for one of the variables, I need to divide the two equations. Why? Because clearly A and A are the same, and division of these two will lead to the elimination of A, but the solving of R. And after I've solved R, I can always get A back by substituting R into one of the equations. So I'm going to repeat this again. We divide the two equations. Why do we divide the two equations? Because dividing leads to the elimination of one of my variables, which in this case is A. So that's why, for instance, I've deliberately decided to say equation 2. Why have I started with equation 2 and then I'm dividing equation 1? It's because I can see the exponent for equation 2 is bigger than the exponent for equation 1. And by that will ensure that I have positive exponents. Remember, when you solve exponential equations, at the end of the day, your answer needs to be expressed having not a negative exponent. Okay, this is like a skill that you cultivate as you do exponents in grade 11. You kind of soon realize that, okay, these people express me to express my answer as without a negative exponent. Why? Because expressing it without a negative exponent is actually the simplification of my answer. So doing that obviously, helps. So now, because you are someone who's in grade 12 now, you are well accomplished in solving exponents and you did it so much in grade 11 and you know the concept, you can't help but apply it in this particular problem accurately. Okay? So like I said, say equation 2 divided by equation 1. And I've been seeing the answers. People have been answering, have been giving me what the value of R is and all of that, which is very good. I'm very happy about that. Okay. Then 512 divided by 8. Do you see this, guys? So the A and the A, okay, they cancel. Or in other words, what is a number? What is something divided by itself? It gives us 1. So the variable leaves. The exponent R, when we have same bases, and we are what? And we are dividing. We keep the base and we subtract the exponents. Okay. And then what's 512 divided by 8, guys? Is 64, Zaz. Okay, Zaza is saying 64. Okay, Kishan is also agreeing. R to the power 6 is equal to 64. Is 64 equal to 2 to the power 6? Okay, I tend to want to believe that 2 to the power 6 to the power 4 written as a prime base. Okay. So let's get something very clear here. Ne? A and A, when we divide something by itself, this is something you learned earlier on in life, that when you divide something by itself as it is, this is A, the exponent is what? Is 1. This is A, the exponent is 1. If we apply the law of exponents, we say A to the power 1 minus 1, which gives us A to the power 0. Okay? A to the power 1 minus 1, which gives us A to the power 0, and anything raised to the power 0 is equal to 1. Okay, so basically our answer is 1. A gets cancelled and we are left with 1. Okay, so this A divided by A gives us 1. All right, when we say cancel in division, we mean that something divided by itself gives us 1, in other words. Okay, because the exponents for the A are both the same. You have to the power 1 here, you have to the power 1 here. So it all goes back to what I said here. If you're going to represent it as exponents, it's like you're keeping the base. What do you do when you are dividing same bases? You keep the base, you subtract the exponents. And then A to the power 0 is actually equal to what? To 1. So yes, A divided by A is 1. That's what we mean. Okay, so this idea of cancelling, because sometimes I think people misinterpret what the cancellation means. The cancellation is not in and of itself a thing of saying that you just make A and A disappear. No. A divided by A number divided by the same number is equal to 1. Something divided by something is equal to 1. Okay, so by that same thing I mean. So R to the power, we do that with R to the power 11 and R to the power 5. We keep the base. When we're dividing, we subtract the exponent. So 11 minus 5 is equal to 6. So that's why we have R to the power 6. Okay. Then 64. I mean, really, there's two ways you could, conclude the answer here. Okay. You can either take the 6th root on either side. You could do that. You'll still get the same answer. If you take the 6th root on the left and on the right, you'll get an answer that's actually equal to R is equal to 2. Okay. Here, same thing. R to the power 6 is equal to 2 to the power 6. All you do is you take the inverse of the exponent on either side. Okay. I don't know if you guys know this. You take the inverse, okay, of 6, which is 1 over 6. That cancels. And then 2 to the power 6. What you do on the left, you do on the right. If you took the inverse 1 over 6 on the other side, that basically also leads to a cancellation. You are left with R is equal to 2. Okay. Yeah. So this is very, very, very crucial or critical. Okay. Also, there's this notion or this idea that you can see that R is raised to the power 6. 2 is also raised to the power 6. So it's almost as if you drop the exponents, you equate the bases. So R is equal to what? To 2. I mean, that notion as well is it's a trail of thought that basically means that R is equal to 2 at the end of the day, because the exponents, they are exactly the same. Okay. But yeah, in exponents, we take the reciprocal, meaning 6. The reciprocal is 1 over 6. So you multiply by 1 over 6. The exponent, the rational exponent, 1 over 6 on the left. Okay. You multiply by the rational exponent, 1 over 6. But what you do on the left, you must do where? You must do on the right. You multiply by that same reciprocal, which is 1 over 6, on the right-hand side as well. And then what's 6 times 1 over 6? That gives you R to the power 1. What's 6 times 1 over 6? That gives you 2 to the power 1. And therefore, what is that? That is r is equal to 2. The 1 we can write explicitly. I mean, we don't really have to, guys. I mean, just something to understand that you take the reciprocal of the rational exponent. Okay. Yeah, Lungile Ndebele, if you just join the live, then I would really encourage you. The thing is, I was actually like coming to the concluding end. How did we get 2 to the power 6 is your question, okay? Guys, if you go to your beautiful calculator, and this is something I always encourage learners to do, pretty please. You see this 512 divided by 8, what did you get? You got 64. Right, and all I was doing when I wrote 64 as 2 to the power 6 is I took my calculator. It's just that I know this off by heart. You write 64, you press shift, you press shift, you press fact from your calculator. 64 is equal to shift fact, and your calculator will give you 2 to the power 6. So that's where that came from. Okay. And the minute I have that 2 to the power 6, then I take my reciprocal exponent, rational exponent. To eliminate this to the power 6, I take the reciprocal. 6, the reciprocal of 6 is 1 over 6. That's the rational reciprocal for 6, 1 over 6. So that 6 times 1 over 6 gives me 1. But if I take the reciprocal to the power 1 over 6 on the left, I have to do it where? On the right. Okay, and that's why I eventually end up with r is equal to 2. Okay, so that's where that 2 to the power 6 comes from. It comes from me changing what I refer to as a composite number base to a prime base with its exponent. All right. Yeah, and these are all like specific things that we learn in grade 11 and grade 10 when we are doing exponents. And that is why, guys, there's so much value in making sure that you do this section. Hey. And I told you in the beginning, you guys, that do not take sequence and series for granted. It allows you the opportunity to revise concepts that you learned in grade 11. And that's why you guys begin with it. Because when you begin with it, it actually helps you to solidify that understanding. Okay. And the Lungile Ndebele, yeah, I was saying, look, guys, that this was actually going to be my last exam, because remember, I do have another grade that I was actually going to also give an opportunity, grade 11, to have a session with. So I didn't intend that it would go on for this long. Remember that my good friend Lungile there, you must know that I have a YouTube channel. I'll be uploading the session there. You can always check it out again and just look at the explanation that I gave for those other problems that I did. Okay, because there were other problems that I did and there were explanations with regards to those problems. Then you can basically check those out. And if you do have further questions, I did say, please do not hesitate to contact me on the side. Send me a message and say, sir, this and that and this and that. Okay. Yeah. Currently, I really, like I said, my heart is to help and assist if I can, as much as I possibly can. Because at the end of the day, maths is so easy, and it's always nice when I can unpack these concepts so that you guys can see the simplicity of this thing. But I can tell you this one thing. You may feel like you think I'm the best teacher and all of those things. At the end of the day, if you do nothing about it, oh my soul, then all of this is just rubbish, actually. Let's just put it like that. I don't even want to, build, it's nothing. So you have to take this and go and apply it. And practice, get your body, your mind, and your heart behind it, so that you can start internalizing some of these things that we did here. Otherwise, what will happen is that the minute you leave this live session, you're going to be like, oh, that was a great session, and that's what it will be. And it will not have an impact in your own personal maths journey. It won't have an impact on your marks. Nothing will materialize. It will just be one of those nice experiences that you had on a Sunday. you know. You'll be like, God is good. He made good, but if you want him to be good, then you must make sure you apply. Faith without works is dead being alone, guys. Faith without works is dead being alone. So go and discipline yourself. Pull out your textbooks and look at similar problems that lead. Like I said, these are problems that require the use of simultaneous equations where sequence and series is concerned. Go and check some more out, guys, and thumb through them and do your thing and do the things. Okay. Since we found R, can we find a teacher? What is this? Since we found R, can we find a teacher? I don't understand what that means. Kanye, is it me? Zaza, I have no specified times at the moment because it's a bit crazy, hey? And it's because it's weekend that I was able to actually at least have just like a brief session with you guys. Yeah, man. Otherwise, in the week it's a bit crazy, but yeah, you guys just need to make sure that you followed and you have a notification so that when I do go live, you can be notified that, hey, this guy is back at it again. And maybe you can catch me. But if you do miss it, you know what's beautiful is that you can always go to my YouTube channel. Go to my bio. On the bio, the YouTube link is there. It's called Maths is a Game as well, the YouTube channel itself. Videos are quite raw. A lot of moving around, as you can see. Like, you see this moving around that you see? Yeah, a lot of moving around. Unedited, very raw. Really starts, because you can see I'm even rambling right now. A lot of rambling, but eventually when I do start, I start, and then you have to kind of like fast forward the whole thing to when I start teaching, and then you just need to endure my ramblings and the sermons and all of that stuff, but we get there. Oh, and me randomly thanking people when they gift me and all of that stuff, and telling Mr. Ngiti to say thank you to Mother. I think Zaza is, does that mean you want to be eliminated? Like, it seems like you want me to take you to the cemetery. And honestly, girl, I don't want to be taking people to the cemetery anytime soon. Hey, yeah, you must have life and you must live for a very long time. Cemetery, no, don't. But I'm guessing you were saying geometry, eh? Okay, I see. Okay, guys, thank you so much. That was cool. Thank you for joining. Really appreciate it. Thank you for the follows. Hey, there were a lot of follows today. Really appreciate it. And also to the gifters. My goodness, I think today I saw the advent of gifts that I have never seen before. It was really appreciated. I really appreciate. Let me see, who was it? I just need to get that name because you can't not make special mention there, There were like hot meals that were being dropped here. Roses. Petronella Daniel came here and just did the things I really appreciated. Oh, Mr. Nda. Yes, it was Nda. Nda lit up my gallery. Really appreciate it. Thank you so much. That means a lot. A ton lot. And also, to those who were here, who commented, comment section, was fire. People were commenting left, right, and center. People were sending, they were sending compliments left, right, and center. Thank you so much, guys. I really get encouraged by some of the things that you say. That's why I keep on going live and all of those things. Some of you who have had the chance to write baseline tests at your school, I saw some of you saying that your baseline tests were the same as what I had uploaded on my page. Guys, that was a big coincidence. It just means I'm inspired sometimes, and therefore what I do post just becomes relevant. Otherwise, do not expect that to happen all the time. Lightning usually strikes once. It does not strike all the time. Okay, but I will be here. I'm just an additional resource, secondary help whenever you need help with the maths. So that's why I'm here, guys. I'm not here to be your primary. I'm not here to take the place of your teacher at school, just here to help and aid and assist as you go along on your maths journey. Maths is easy, guys. Maths is fun. Maths is a game. You play it long enough, you play it hard enough, you learn the rules, you figure out how each game is played. And then you pass with distinctions, man. And it's just like that. And that's why some of our kids, they just get 100%, clean. It needs someone who can consistently play it. If I am the rule master and I show you how the game is played and I show you the rules and you're like, yo, okay, it's finally making sense, then you need to take that fire of what makes sense and you need to go and practically apply it so that you can see yourself finally become that math student that you've always wanted to be and getting the marks that you actually want, because it's possible. Okay, thank you so much, guys. Thank you, Grade 12s. Much appreciated. I'll check you out on the flip side. Maths is a game. Let's play. Booyah!